Welcome to today's session, Streamlining Oracle Applications from On-Premises to VMware Hybrid Cloud. My name is Sudhir Balasubramanian. I'm a Senior Staff Solution Architect and Oracle Practical Lead for VMware. I'm joined by Don Sullivan.
Hi, I'm Don Sullivan. I'm the Product Line Marketing Manager for all of Business Critical Applications, VMware. The two of us have been together for a combined 20 years. We've written multiple books on this particular subject, and we'd like to share all of that with you as much as possible within the next hour.
All right. So let's take a look at the agenda for today's discussion. Essentially, we'll start with talking about benefits of running Oracle workloads on a VMware platform. We'll talk about what customers want, essentially VMware Hybrid Cloud. We'll talk about the VMware Cloud on AWS, the benefits, the use cases. We'll also talk about deploying and migrating Oracle workloads on VMware Cloud on AWS. We'll follow that up by licensing guidance on Oracle workloads on VMware Cloud on AWS, a bit on support, a bit on certification, and we wrap up with a lot of documentation and links. But moving on to the next slide. So essentially, let's start by looking at the benefits of running Oracle workloads on a VMware platform. So, even before we look at the advantages of virtualization, the first thing that we have to understand is what Oracle Business Critical Application or BCA, what are the requirements, right? Because every business critical application, Oracle or SQL Server or SAP, they have a set of stringent requirements, right? So we need to understand what the requirements are and then understand the benefits of running these business critical Oracle workloads on a VMware vSphere platform. So any application that is deemed BCA or business critical will have certain SLAs, they will have certain RTO, they'll have certain RPOs. Essentially, they'll have a set of stringent requirements. For example, availability. Well, this particular application must be highly available, it must be resilient, it must be redundant, etc. Right? Performance. Timely process completion is very critical. One must make sure that any kind of bottlenecks are avoided. When we start talking about recoverability, right? So, terms like RTO, RPO, MTD, WRT, they must be very low. And the fact that the recovery plans must be verifiable and repeatable, right? When you talk about scalability, the fact that these applications should be able to scale up, the infrastructure should be able to scale out in order to make sure that the applications are able to scale up and scale out. Security is very inherent, right? And security, and we have to make sure that the applications are compliant with the industry standard security practices. So, when we look at this slide here, there are many more benefits. It's not particular to any business critical workload or any business critical application vertical. This essentially helps all workloads, right? For example, resource maximization or even enhanced availability, etc. Don?
Yeah, so Sudhir, I think a good point is that the historic truth of everything that we're saying here is borne out by the fact that these themes are have been around for a very long time. We started talking about these individual themes probably in the 2010 timeframe, and they've met the test of time from really looking at Oracle running only on vSphere to the software-defined data center, in which we included the networking and the storage, to now the hybrid and multi-clouds. It's still the same set of themes that apply to not just Oracle, but all business critical applications.
That's correct. Right. Moving on to the next slide. So essentially, like we spoke about we spoke about the stringent requirement in the previous slide, right? In this slide, we speak about some of the benefits. And again, this is not particular to Oracle Business Critical Application workloads. This essentially helps all critical workloads on a VMware vSphere platform, right? For example, we spoke about resource maximization. The fact that server resources, they increase too much for one application instance. By virtualization, you're able to improve the resource utilization, you're able to reduce wastage, right? The fact that you have enhanced availability. For example, if one were to run Oracle RAC on a VMware vSphere platform, you get the advantage of having application level HA on top of VMware vSphere infrastructure level HA. And at some point of time, if we were to stretch that infrastructure across metro distance, what we also get is site level HA. So simply by running an extended Oracle RAC across metro distance on a VMware vSphere platform, which is stretched across metro distance, one gets 3 levels of HA: application, infrastructure, and site level high availability, right? Some of the other benefits include rapid provisioning and scaling. You get lower TCO, right? so on and so forth. Dev test, the virtualization, the platform that improves adaptability and elasticity.
You got it, Sudhir. Just we can look at this slide and really get an understanding of the most important aspects of vSphere, the depth of vSphere. Again, these historic features, the simplicity of high availability that I have forever referred to as Fisher Price high availability, because you could apply high availability to an entire vSphere cluster in a couple of mouse clicks. vMotion, that capability that made the server moved it from a physical concept to a logical concept, so that you could take a running server with a running database and applications and transition it to a different server without it going down, and then building that in to a load management system that has evolved every single different version of VMware over the years in dynamic resource scheduler. But I stole some of your thunder there, Sudhir, so keep going.
And absolutely. So, I mean, you definitely touched upon all of the main important points here, right? You spoke about VMware HA and the fact that now VMware HA with the recent versions of vSphere is more proactive than reactive before. The fact that vMotion has been enhanced immensely, and we have a slide that talks about that on VMware vSphere version 7.0. And the fact that DRS, the distributed resource scheduler, is now more proactive than reactive. And for example, right, if DRS were to detect a component is failing, or let's say a server is failing, what DRS would do is automate. It will send an email out, or it could, if you were to set automation up, but it would alert the user saying, hey, this particular server is failing or this particular component is failing. I think it's time for you to move your workloads to a different server. And then based on the level of automation, whether that's manual or that's fully, it will do the work for you. So DRS has now become more proactive than it used to be before, where it was more reactive. All right. Okay. So with this slide, the context here is the processors are getting faster, right? Caches are getting bigger. The NUMA awareness is getting better and better. And hypervisors, they're getting more smarter. Of course, storage is getting more faster as well. Well, all of these factors, it makes a perfect sense for virtualizing any application or most of the applications, right? So with each version, VMware has been increasing the performance and scalability by leaps and bounds. And any lingering performance concerns relating to VMware virtual machines, they are clearly due to a lagging perception from very early generations, which I agree, it have very limited capabilities. But then the link at the bottom of the slide, the config max, that basically shows the version of vSphere and the maximum configurations that a virtual machine can have, with respect to, let's say, the number of PV-SCSI controllers, the amount of VRAM, the amount of vCPUs, the amount of network adapters.
So, Sudhir, I'll add this on just in case there's one person out there that has never heard either one of us talk before and has not heard the slide. This is truly our favorite slide of everything that we've worked with. And the reason is because we worked with it from the very beginning, and we have it updated now to the very end. That is vSphere 7 update to the most recent version. And it covers all 4 dimensions of performance, as we call them: the processing, the memory, networking, and of course, the most processing and the most intensive when it comes to actually calculating the overhead of the virtualization level, that is the storage access. Take it away, Sudhir.
Absolutely. All right. So essentially, this slide reiterates the same point. So, for example, if one more on vSphere 7.0, if you look at the number of SCSI adapters, the virtual SCSI adapters, PV-SCSI, you now have a maximum of 4 PV-SCSI adapters with a maximum of 64 VMDKs per PV-SCSI adapter. That gives you a total of 256 times a VMDK can go to a max of 64 terabyte minus 2 terabyte for metadata. So one could do the math. I mean, that's the amount of storage space that a virtual machine can address. And the fact that starting from 7.0 U1, hardware version 18, you can support up to 768 vCPUs. And the fact that with 7.0 U1, you're now able to support 25 terabyte of VRAM. right, for a virtual machine. So the number of vCPUs have increased, the number of VRAM that a virtual machine can address has increased, the amount of storage space that a virtual machine can address has essentially increased from 6.7. So we are increasing the config maximum for the virtual machine or for the workloads, but leaps and bounds from every version of vSphere. So again, the link at the bottom of the slide, the config max, that basically would show you the version specific config maximums for a virtual machine.
And I don't know if anything has changed for update 2 in this slide. I don't think so, but we might get back to you on that. Go ahead.
Yeah, no worries. All right. So let's look at some of the vSphere 6.5, 6.7 new features for business critical applications. So I'm not going to go into the entire list of the new features. I mean, there's a lot of new features that were released with 6.5 and 6.7, but some of the notable ones are persistent memory, para-virtualized RDMA drivers, and the fact that you have 512E drive support, right? And one of the day 2 operations, I mean, one of the features which is very critical for day 2 operations, in my perspective, my opinion, is the automatic space reclamation, the unmap feature, where, you know, from a database perspective, one were to go and drop a bunch of, you know, data files, or let's say table space, or let's say a lot of objects, right? And at some point of time, right, Oracle would then decide to inform the guest operating system, which at some point of time should be able to inform the VM kernel and the underlying storage that, hey, so much of space has been deleted, go ahead and reclaim it. So that's what the automatic space reclamation is, the unmap feature. So that is very important from a day 2 perspective. And again, we spoke about the fact that now DRS and HA is more proactive than reactive. So these are some of the features that were released as part of 6.5 and 6.7. As part of 6.7, a notable feature was a 1 gigabyte large memory page. Essentially, you know, all along, ESXi had this flavor of 2 megabyte, you know, large, huge pages, the large pages, right? As Linux operating systems do support. But with 6.7, ESXi also has what's called the 1 gigabyte large memory pages. It's more opportunistic. So we are now able to protect virtual machines, right, with large pages as large as 1 gigabyte. So the links at the bottom of the slide essentially talks about the new features, and also the links also include the performance best practices guide for vSphere 6.5 and 6.7 version.
I think you haven't mentioned, Sudhir, the fact that there are a lot of collateral that has been developed that is accessible through, you haven't mentioned the one-stop shop yet, but for everything that's circled in the dotted line red there, and for the vSphere 7 versions as well. So
absolutely,
that's definitely something that the listener, the viewer may be interested in getting a hold of if they're really deeply interested in these rather technical subjects.
Yep. All right, switching gears, let's look at vSphere 7.0, some of the new features for business critical applications, right? So with the latest release of vSphere 7.0, there's been a lot of features added. So we essentially won't have time in the session today to go through all of them, but I do want to call some of the notable ones out for business critical application, namely improved DRS, right? Improved distributed resource scheduler, assignable hardware, refactored vMotion. Again, the link at the bottom of the slide basically goes through some of these features in detail. But moving on to the first one, the improved DRS, right? So with vSphere 7.0, right, we came up with this feature called the improved DRS. So vSphere DRS is to focus on the cluster state. It is to check if it needs rebalancing, because it could happen, right? One ESXi host is overconsumed while the other ESXi host has less resources consumed. So if the DRS logic that determined it could improve the cluster balance, what it does, it would recommend and it executes a vMotion depending upon the configuration, depending upon the settings. So that way DRS used to achieve the cluster balance by using what's called the cluster-wide standard deviation model. With vSphere 7.0, the new DRS logic, that takes a totally different approach. It takes a completely different approach. It computes what's called a VM DRS core on host, and then moves the virtual machine to a host that provides the highest VM DRS core. So the biggest difference between the old DRS version and the new DRS version is, right, it no longer balances the host load. It means DRS, what DRS does now is it cares less about the ESXi host utilization baseline. We now improve the workload balancing on the cluster by focusing on the metric that we care about the most, which is the virtual machine happiness. So the important thing to note is that improved DRS, right, that runs every minute. So that provides for a far more granular way to calculate the workload balancing. And what happens is this results in an overall better performance for the workloads. Tom?
Oh, don't have anything to add to that. I think you covered it very well.
Okay. All right, let's talk about assignable hardware. So the new dynamic direct path IO and the NVIDIA vGPU, what they are both using what's called the assignable hardware framework, right? So the dynamic direct path IO, that's a new way of configuring pass-through to expose PCIe devices directly to the virtual machine. So no longer is the hardware address of a PCIe directly mapped to the configuration of the .vmx file of a virtual machine, right? But what we do right now is we expose the PCIe device capability to the virtual machine. So for example, if VM needs a GPU of, let's say, model B100, correct? So the assignable hardware will no longer interact with DRS to find an ESXi host that has such a device available. What it does, it'll claim that device and it'll register the virtual machine to that host. Now, when a VM is vGPU enabled, DRS is capable of finding ESXi host that has the same GPU profile available. So what happens is, because of this abstraction of the PCIe devices, vSphere 7 is now able to do initial placement with the DRS for the dynamic direct path IO enabled VMs. What this means is vSphere HA is also supported, or it's supported so that workload availability is improved. Because if an ESXi server fails, vSphere HA, vSphere DRS will try to find a similar device on a surviving ESXi host in the cluster. Of course, this all depends on the device availability in the cluster. Anything, Don?
Nope, no more.
All right, so let's talk about vMotion performance improvements and what is it that actually changed in vSphere 7.0. So the key takeaway is, with the previous vSphere features, right, with the previous vSphere versions, right, what happened was we installed page traces on all of the vCPUs of a virtual machine. So anytime a virtual machine is getting vMotion from one ESX server to another, what happened was we installed page traces on all of the vCPUs. Now that did cause a bit of performance workload impact, right? Also during the stun time, we transferred the full memory bitmap, right? What happens is, with essentially with the large or with the monster VMs, this could be a fair amount of data depending on VM sizing. So what we decided was we had to bring back the vMotion capability. We had to reduce the performance impact. We had to reduce the stun time, right? And this is what we did with vSphere 7.0. So on 7.0, we claimed one vCPU. So for a virtual machine, we pick one vCPU to do all of the page installing and the page firing, right? Essentially, the memory page is overwritten by the guest instead of doing it across all of the vCPUs configured for a virtual machine, right? So by using this method, it's far more efficient because the guest, the workload, they can continue to use all the remaining vCPUs without interruption, right? So we dedicate one vCPU for doing this work. So one vCPU will take care of setting all the page table entries, the PTE in the global memory to read only and handle the page tracer installer and the page firing. And at the end, what happens is all of the vCPUs will still need to flush the TLB or the translation look-aside buffer, but now this is done at different times to reduce the performance impact. So from a vSphere vMotion perspective, right, by dedicating one vCPU to do the page tracing rather than having the page tracing done by all the vCPUs, right, we are now able to reduce the stun time. We are able to now increase the performance of the vMotion operation.
I think something else you probably want to add to this, Sudhir, is how the capabilities that have been added all the way up through 7U2 now of being able to use larger networks, larger number of network cards so that the vMotions can occur in parallel, and having that all happen automatically rather than having to be configured in sometimes onerous ways by the actual user. So we keep making a classic, incredibly impactful feature such as vMotion better and better. I find that amazing.
That's an important point, yes. All right. So let's look at the Oracle workload design methodology. I mean, this is the overview of the Oracle workload design methodology, right? So the start is essentially by gathering requirements. And at some point of time, we would sell the project to the stakeholders. What would then happen is we would understand the current environment constraints. We would then measure the workload. At some point of time, you would have to migrate the database from the source to the target. The source could be Solaris, AIX, HPUX, or even the physical x86 over to the VMware platform. Then you would then inculcate support and licensing, making sure that you inculcate best practices, which is design considerations for sizing. Then follow that up by day 2 operations, right? Backup recovery, high availability, DR, and last but not the least, monitoring and tuning, which is of utmost importance, right? But if you look at all these steps of the design workflow, there is no one step that cries out. There is no one step that is particular to an architecture, whether it's physical or virtual. So all we're trying to say here is there is no change in the design methodology when one virtualizes Oracle workloads on a VMware platform as compared to running Oracle workloads on bare metal.
I'll reiterate something I said earlier. This is another slide that we've been using for a long time. Why? Because it's completely valid. The methodology is valid. Whether you were still running completely on premises, whether you're running in a software-defined data center architecture, whether you're on a hybrid or a multi-cloud, or whether you're running on an on-premises cloud, or all of them together, this methodology still applies.
Yep. All right. So this slide talks about some of the performance best practices, right? Essentially, the key thing to keep in mind, best practices needs to be inculcated into every layer of the stack, including the virtualization layer, to ensure that the workload can take advantage of the underlying stack. So for example, we are all global resources. We talk to customers, we talk to the field every day of our life, right? So at some point of time, if a customer were to run up to us and say, hey, can you give us a run book as to how one would run or one would run Oracle workloads on, let's say, vSphere 6.7 or vSphere 7.0, our advice is read the performance best practices for vSphere 7.0 version first, and follow that up by reading the Oracle databases on VMware best practices guide, and essentially putting these guide together and stapling that, if one would, gives you the actual run book that a person is looking for. So from a performance best practices perspective, right, things like using para-virtualized SCSI adapters, right, using multiple vSCSI adapters up to 4, making sure that you enhance the queue depth or set the queue depth for the VMDK and the PV-SCSI to the maximum, making sure that you use huge pages, right, making sure that you don't overcommit your CPUs, right, your vCPUs, making sure that you look into exactly how much memory that you require, right, and use the appropriate amount of memory for the Oracle workload. But the nuances like these are very important when one needs to size business critical Oracle workloads on a VMware vSphere platform. Anything done?
Yeah, Sudhir, I'll ask you a question here, because it's honestly something I don't remember. For a while, there was an issue with using the huge pages setting inside Oracle as being contradictory to the huge pages setting inside the OS and with vSphere. Are there any issues with that anymore?
I think what you're referring to is with NUMA. So with huge pages, there were never a problem, right? Essentially, the issue was with enabling NUMA support in the Oracle database. So with 10G, Oracle introduced the NUMA support. Essentially, that caused a lot of disconnects, that caused a lot of issue in the Oracle layer. Again, this is nothing to do with VMware per se, right? This is independent of VMware or any physical architecture, right? But with 11GR2, what Oracle did was it disabled the automatic NUMA enablement and essentially gave the control to the Oracle DBAs to set NUMA, right, or virtual NUMA as and when they choose to for the particular workload. So that's why the number of vCPUs, or the fact that you don't want to enable hot add vCPU up to version 7.0, because that disables the virtual NUMA, which is very critical when you run Oracle workloads on a NUMA hardware, right? Because the operating system, the Oracle database needs to be NUMA cognizant in order to make sure that it uses all of the capabilities of the NUMA nodes and the underlying hardware.
Good answer. Let's go.
All right. This is very obvious to the listeners here, but essentially, the first thing that we say is read the documentation first. There's a reason why these documents are written. These are lessons learned from the field. And at some point of time, one would then deploy virtualized workloads in production with best practices, right? And then one would accelerate these workloads using vSphere new features. Now, whether that's persistent memory, that's para-virtualized RDMA drivers, whether that's using vMotion, the enhanced capabilities of vMotion, or assignable hardware or GPU, so on and so forth. And at some point of time, one would then spread their wings and then think about making the journey to any one of the VMware hybrid cloud, which we will speak about in the forthcoming slides. Anything to add on?
Nope.
All right. All right, let's change gear and talk about Oracle PeopleSoft workloads on a VMware hybrid cloud. So again, September 16th, 2019 is when there was a landmark change to the metaling node 249.212.1. Essentially, if you look at the screenshot on the right, there was a lot of verbiage in the older version of the metaling node as part of Open World 2019, the agreement between VMware and Oracle, where there were two offshoots. One was the Oracle Cloud VMware solution, the joint product, which is solely hosted, managed, and operated by Oracle. And the second offshoot of that was the landmark change to the metaling node 249.2.2.1. Essentially, all of the verbiage that you see in the right has been cleaned up neat, and essentially it says for any and all versions of Oracle, right, is supported on a VMware virtualized environment, including Oracle RAC, as early as 11.2.02, starting November 8, 2010. And again, go ahead, Don.
For those skeptics, it was Larry Ellison himself who did the announcement at Open World, something that I refer to and will continuously as the miracle at Moscone.
Yep. All right. So the question that typically people they ask us as well is VMware supported by PeopleSoft. So this is a screenshot from the metlink, and the doc ID is there in the top of the slide 847.092.1, and essentially it says, essentially says, right, is PeopleSoft supported on a VMware hybrid cloud? Is it certified, so on and so forth? The one thing that I would like to draw your attention to is, keep in mind, Oracle only certifies their product, including PeopleSoft. So whether that's PeopleSoft, the People Tools, or whether that's Enterprise One, on operating system. And those operating systems includes Lattice, HP UX, Linux, Microsoft Windows, AIX, etc. Right? Oracle does not certify the product to specific hardware configuration. So therefore, as long as a customer configures the machine with the supported operating system, we will treat them as though they're independent systems and provide full support. This is essentially what Oracle has said in the note here today, has said here in the note. So as you can see in the note, as you can see in the note, it very clearly mentions, please also see the Oracle corporate policy on support for VMware virtualized environment. And the note is a 249.2.1.1, which very clearly says all Oracle products are certified, or all Oracle products are supported on a VMware virtualized environment.
So it's probably a good time, Sudhir, to remind everyone that vSphere should be thought of as hardware. vSphere is a platform of virtualized hardware. So that makes what Sudhir just said about the certification of Oracle software to operating systems, which of course run on hardware, even more pertinent.
Yep. All right. So for example, if we were to check the certification matrix of PeopleSoft, the People Tools, right? For example, 8.5 version, the details are there on the mysupportoracle.com site. We can clearly see that PeopleSoft, the People Tools 8.58, well, that is certified to RHEL 6 and to RHEL 7, and also to OEL 6 and OEL 7. Right? And for databases, it's compatible and certified with Oracle 93. So all we're trying to say here is, if you look at the certification matrix, there are just 3 columns here, right? The column to the left is the product, the column in the middle is the release number, the column on the right is the platform. You do not see a 4th column that says hardware. So again, reiterating the point, Oracle products are certified to operating system and operating system alone. So the key thing to keep in mind is, as long as we run certified Oracle products on a certified operating system, we keep the Oracle vendor happy. And as long as we run the same certified guest operating system on a supported certified VMware vSphere platform, we keep the VMware vendor happy. So the name of the game is to keep both the vendors happy here, Oracle and VMware.
I think it's also important to note, since we haven't yet in this particular session, that the innate most important part of vSphere is that hypervisor, Elastic Sky, ESXi, which is a non-paravirtualized type 1 hypervisor, which translated means there are no changes made to the operating system at all, which means that the applications running, in fact, the operating system, has no idea that it's running on a non-physical hardware versus physical hardware. It's the same thing to it.
Correct. I mean, in fact, to your point, Don, I mean, there is no line in the Oracle alert log file that says, essentially says this Oracle database or this particular workload is running on a VMware vSphere version. It would just say Oracle database is running on this particular operating system. So again, the VMware vSphere platform is completely transparent to the overlying applications. All right. So switching gears, what do customers really want? What they're looking for is VMware hybrid cloud. So as customers, they move to the cloud. I mean, essentially, they're looking for ways to get best of both the worlds, right? Without buying new hardware, without refactoring or without replatforming. And what they want to do is they want to leverage their existing investments, their existing skill set, and the tools, right? So if you look at the diagram or the figure on the screen here, essentially with on-premises, they are able to use familiar tools, they're able to use familiar processes, they're able to leverage existing investments, they're able to maintain unique hardware configurations, they are able to have a granular control over placement of the applications and the data. Now, with public cloud, on the flip side, you're able to scale faster, you're able to reduce cost, you're able to establish the global footprint, you have the pay-as-you-go model, and you're able to access a broader range of services, right? For those customers who want to adopt the cloud, right? Essentially, some of the top cases that we have seen, the top use cases that we've seen is cloud migration, data center evacuations, and that is followed by disaster recovery or data center extension. So these are some of the use cases that we have seen. You know, when one wishes to go to the cloud, thing to keep in mind is with any of the cloud that we are looking to migrate to, right? The key thing here is application and infrastructure rework. That takes like 90% of the time. And the best part is with VMware Hybrid Cloud, if one were to connect a layer 2 VPN or over direct connect or even through internet, if one were to have a layer 2 VPN connected to any other VMware Hybrid Cloud, namely that could be VMware Cloud on AWS, or that could be Google Cloud VMware Engine or Azure VMware solution, or even Oracle Cloud VMware solution, the fact that you are VMware on both sides, both on premises and the cloud, there is no application refactoring. There is no application rework. There is no downtime, right? Essentially, you don't have to go and change the IP address, right? Once you reach the cloud. So by simple right-click vMotion, one is now able to send their workloads or migrate the workloads from on-premise to the cloud and back, as long as they have the layer 2 connectivity between both the on-premises and the public cloud.
In a VMware hybrid cloud, vSphere is ubiquitous. And that's why what you're saying is so true. It's all the same everywhere in terms of anything that we're talking about here.
Yep. So spoke about some of the VMware hybrid cloud offerings. VMware Cloud on AWS, that was GA'd on 2017. We have the Oracle Cloud VMware solution. We had the Google Cloud VMware Engine. We also had the Azure VMware solution. So essentially the link at the bottom of the slide that basically goes into some of these offerings. And then there are some blog links here as well that talks about these offerings in detail. Well, moving on. All right. So this session will focus on VMware Cloud on AWS. What are the benefits? What are some of the use cases here? All right. So with VMware Cloud on AWS, right, or VMC as we call it, right, together with VMware Hybrid Cloud Extension, HCX, what it does is that enables customers to accelerate their cloud migration in the simplest, fastest, and the low-risk way with compelling TCO. So with VMware Cloud on AWS, what it does is it brings VMware Enterprise Class Software-Defined Data Center, SDDC software, to the AWS cloud and enables customers to run production applications across VMware vSphere-based private, public, and hybrid cloud environments with optimized access to AWS services. Now, VMware Cloud on AWS, that's delivered, sold, and supported by VMware and its partners as an on-demand service. that enables IT teams to manage their cloud-based resources with familiar VMware tools. I mean, without the hassles of learning new skills or let's say utilizing new tools. And if one were to open the covers, I'm oversimplifying this. If one were to open the covers of VMware Cloud on AWS and look inside or peek inside, one would see the familiar tools that we have been working with for a long, long, long time. VMware vSphere, VMware vSAN, VMware NSX, along with VMware vCenter. So essentially what I'm trying to say here is these are familiar VMware tools that customers have been working for a long time, and that's essentially what VMware Cloud on AWS is, right? So essentially, it's all of these software that is optimized to run on a dedicated, elastic Amazon EC2 bare metal infrastructure. Well, that's fully integrated as part of the AWS cloud.
So obviously, the same theme applies to any of the VMware powered clouds, anything that is a VMware cloud, with different underlying physical mechanics. So I'll put it that way. But here we're talking about AWS.
Sure. All right. So let's talk about how we can deploy and how we can migrate Oracle workloads on VMware Cloud on AWS. So we'll talk about the deploying methodology first, and then we'll follow that up with talking about how we can migrate Oracle workloads to VMware Cloud on AWS. All right. So let's look at this example setup, this architecture diagram. Essentially, we have a 3-site lab setup, right? That includes the on-premises site A, includes the on-premises site B, and with connectivity to VMware Cloud on AWS. So the on-premise vSphere cluster on site A, that's running production workloads. The site B is running dev, test, and DR workloads. That's typically how any customer environment would be set up, right? You would have the production workloads on site A, you would have your DR, you would have your test, and you would also have your dev, some of your dev and test on site B. Right? That way you want to keep both your DR and your production on 2 different metro zones right here. So both site A and site B, they are in a hybrid link mode, right? Site A and site B. As shown here, they have access to dedicated storage, and Site A is connected via layer 2 VPN to VMware Cloud on AWS. Now, this VMware Cloud on AWS, essentially that's set up in a stretched cluster deployment. It's a 6-node stretched cluster for VMware Cloud on AWS across 2 availability zones or 2 AZs. Essentially, what we have is 3 servers on AZ1. You have 3 servers in AZ2. Storage in VMware Cloud on AWS, that's provided by the HCI vSAN instance. So this current solution that designed and deployed 3 separate environments. So as we see, Site A on the left, that had a 2-node production Oracle rack. Site A also had what's called the production Oracle FarSync. Site B has a 2-node Oracle rack. That's a disaster recovery Oracle rack. And then now let's take a look at migrating single instance Oracle workloads to VMware Cloud on AWS. So essentially, from a very high-level perspective, right, Oracle workloads migration from on-premises to VMware Cloud on AWS, that can be done in one of the 2 ways. Either using the native VMware and Oracle methods, or by using VMware HCX or hybrid cloud extension. So we'll talk about the native VMware and Oracle methods, and we'll also talk about HCX in the forthcoming slides. All right. So let's see how we can deploy Oracle non-rack workloads on VMware Cloud on AWS. Right. So deploying standalone Oracle workloads on VMC or VMware Cloud on AWS, that's exactly the same as one would do on premises. Right. With VMware Cloud on AWS, ESXi hosts traditionally, they reside in an AWS availability zone or AZ, and they are protected by vSphere HA, high availability. So this particular use case, it deployed a virtual machine from a template, right? And the operating system was OEL 7.4 operating system, grid infrastructure, RDBMS binaries 12.2, and then the Oracle SG and the Oracle PJ was set to the predefined limits. And we basically use Oracle ASM and Oracle filter driver, right? The key thing to keep in mind, all of the best practices for Oracle workloads on VMware SDDC, that was followed in accordance with the Oracle databases on VMware best practices guide. And essentially, to reiterate the point here, deploying any Oracle workload on VMware Cloud on AWS, so for the matter of speaking, on any VMware hybrid cloud, that's exactly the same as one would go about doing it on premises.
Go ahead,
right.
Sudhir. Yeah.
Sure. All right. So let's talk about stretch clusters for VMware Cloud on AWS. So with VMware Cloud on AWS, right, as I mentioned this before, ESXi host by default, they reside in a single AWS availability zone that's protected by vSphere HA. So a feature called stretch clusters for VMware Cloud on AWS, well, that's designed to protect against an AZ failure, an availability zone failure. What happens is applications can now span multiple AZs within a VMware Cloud on AWS cluster. So the vSAN fault domain, they are configured to inform vSphere and vCenter which host resides in which AZs. And to increase clarity, what we did was each fault domain is named after the AZ it resides within. So what one could do from an Oracle workload perspective is, we can deploy our Oracle workloads on stretch clusters for VMware Cloud and AWS. And in the event of any AZ failure, so whether that's AZ1 failure or AZ2 failure, what happens, and again, these AZ failures are very, very, very rare. The workloads are then brought up on another availability zone without any breach of SLAs or RTO or RPO, right? What one could also use these stretch clusters for VMware Cloud and AWS as is for load balancing. So if one had to load balance your workloads across multiple AZs, one could do that as well, right? So deploying and migrating Oracle workloads from on-premise to VMC, that has been documented in a detailed reference architecture guide, which is provided in the resource pages, and also the link has been provided at the bottom of the slide here. Anything, Don?
Just that, and I'll continue to say this, we're obviously focusing on VMware Cloud and AWS. Much of what we're saying, without getting into the details and mechanics and nuances, applies in different ways to the other VMware powered clouds as well. We just choose here to focus on the VMware Cloud and AWS.
Yeah, that's a good point. All right. So we spoke about deploying Oracle workloads on a VMware Cloud and AWS, right? Now let's change tack and talk about how we can migrate Oracle workloads from on-premises to VMware Cloud and AWS and back, right? So this use case talks about how we are able to migrate a single instance Oracle virtual machine on-premises to VMC or VMware Cloud and AWS transparently in a couple of mouse clicks. So this particular virtual machine was running Oracle Enterprise Linux OEL 7.4, Oracle Grid Infrastructure RDBMS binaries 12.2, again, Oracle ASM using filter driver, and this was using a multi-tenant option, essentially running a pluggable database, PDB1, right? So looking at the steps, right, we basically use the same mentioned steps here, which is shown in the slide, wherein what we do is as part of the migration method, we choose the resource pool, we choose the storage, we choose the destination network port group. We can then seamlessly, by a right click, transparently migrate that single instance workload to VMware Cloud on AWS. And essentially, if we have to migrate back to on-premises, we would follow the same steps. So the blog that speaks about this particular process in detail, I mean, that's the link is there in the bottom of the slide. There's also a demo YouTube video that we recorded. And again, you would also see this content. This content can also be viewed on the reference architecture that we spoke about in the bottom of the slide as well.
Next slide.
All right. Okay, so all along we were speaking about using the native Oracle and the VMware method of migrating, or let's say of deploying Oracle workloads on VMware Cloud and AWS, right? So this particular section addresses the second way, essentially by using the VMware Hybrid Cloud Extension, the HCX. So with this approach, what VMware HCX or Hybrid Cloud Extension does, it basically abstracts on-premises versus cloud notions. And what it does is presents capabilities to a virtual machine as a continuous hybrid cloud, right? It provides minimal operational overhead without requiring any kind of retrofit of legacy infrastructure, right? So when you look from an HCX perspective, there are 4 HCX-enabled migrations. You have the cold migration, the bulk migration, the hot, and the vMotion with the vSphere replication. So we won't have time to go into every one in detail, but the reference architecture, the link at the bottom of the slide basically goes into every one of the HCX methodologies of doing it. So essentially, to summarize, you have one of the 2 ways of doing it. Either we can fall back on the native vSphere Oracle ways of migrating or deploying the workload from point A to point B, point A being on-premises, point B being VMware Cloud and AWS, or you could use the VMware HCX, the hybrid cloud extension, to migrate your workload, whether that's using cold migration, or whether that's using bulk migration, whether that's using hot migration, or even replication assisted vMotion to move it from on-premises to VMware Cloud and AWS.
So, Sudhir, I don't think it's possible to exaggerate how amazing HCX really has been, is, and how it's been developed. I think that Captain Kirk and Mr. Spock would be amazed if they understood that in 2021 we were able to actually take entire VMs and vMotion them with the storage between these various completely disparate cloud systems. It's really amazing, and the audience themselves should familiarize yourselves with it as part of your, and to incorporate it into your part of your overall architecture.
That's absolutely correct. Basically, this is what SCX does. It beams up the Oracle workloads from on-premises to the cloud and back.
There is intelligent life down here, Scotty.
All right. So let's talk about licensing Oracle workloads on VMware Cloud on AWS.
Everybody's favorite subject.
Yep. Don, do you want to take this one?
I think it's worth stating, and trying to keep this really short, that there are a number of different approaches to how to go about understanding the licensing discussion overall. But from a basic perspective, nothing changes in regards to the basic fundamental licensing of Oracle running on vSphere, no matter where vSphere is. And I honestly don't think in a session like this, it's worth spending a lot more time on it. I do think it's really important that the customers understand the details underneath what I just said, and to come to VMware, go to your sales teams, get a hold of us. We may advise you to seek out the help of one of our expert, really special forces partners in the industries. If it goes further than we are able to go with you in terms of a discussion or representation. It is important to understand the Oracle licensing and service, or licensing and standards agreement, as well as the Oracle master agreement, depending on when you initially, when you actually signed your agreements with Oracle, will determine which one of those agreements is actually the agreement that is going to determine what matters related to your licensing situation. But for the most part, nothing really changes. And the main idea is that you are licensing based on cores that the Oracle software has been run and or installed on. And for the most part, without getting into some of the other nuances having to do with special cloud arrangements that have been made that really don't apply to this conversation. Again, as I mentioned, nothing changes from that basic premise.
Yep, very good. All right, some more facts about VMware Cloud on AWS. Essentially, September 6th of 2018, we came up with compute policies. So essentially, now we are able to assign tags, right? We're able to assign tags to a simple virtual machine, right? To come up with this virtual machine to host affinity. Keep in mind that these are preferential policies, and these preferential policies cannot block a host from entering into maintenance mode. So that's why our recommendation is, if one were to go with an N as a Nancy number of nodes that you require to sustain an Oracle workload, what we recommend is you license one extra server worth of Oracle licensing. That way, you are able to now compensate for the maintenance or the or any kind of maintenance activity, right? And at some point of time in 2018, which is September 10th, we came up with the minimum 3 hosts and the maximum 16 host SDDC. Essentially, we reduced the number of servers that an SDDC can sustain or can have. And in 2019, what we did was, and this is essentially done for Oracle licensing purposes, we reduced the number of cores that a server can have in an SDDC cluster, and that's from the second cluster onwards, right? So essentially, for i3 clusters or for i3 SDDC clusters, one could go as low as 8, 16, or 36 cores per server. For i3 and R5 is essentially deprecated, one could go as low as 8, 16, and 48 cores per server. So we are now able to go with reduced number of cores per server and reduced number of servers per SDDC cluster solely and wholly for Oracle licensing purpose to keep the core count down.
I'll just add this to sort of follow up on what I said in the last slide. That is fundamentally straightforward as the concepts are. It is very easy to get caught up in the weeds and get yourself confused in regards to the various different versions and the numbers of cores and so on. And so it is very important to understand the details of your own environment, understand the nuances of any cloud implementations that you're using. And since I am constantly finding different baseball analogies, it is very important to, if you're going to face major league pitching, to be a major league hitter. So really have someone who understands the concepts of Oracle on VMware technologies licensing when you make your final architectural decisions and you determine how you're going to run from here on out.
Yep. All right, so let's quickly talk about Oracle support on VMware, the three pillars of support. Essentially, the first pillar of support is the metallic node 249.212.1 that unequivocally says, right, all Oracle products are supported on a VMware virtualized environment. The second pillar of support essentially is the VMware total ownership of support policy that inherently states, right, every Oracle on VMware issue or any Oracle on VMware issue will be resolved by VMware GSS, right? Any issues, starting from beginning to end, and then VMware has the onus of making sure that we put these cases to rest. And the last but not the least, the third pillar of support essentially is the TSSNETorg. Think of that as a Geneva Convention or a consortium where you have all these companies, and including Dell EMC, you have HP, you have Oracle, you have VMware. Essentially, all these companies, they come together, they pledge to make sure that none of the customers or the mutual customers will be put in any kind of issue. So with these three pillars of support, and Don, you can add to this as well, right? We are now able to talk to Oracle. We are now able to reach out to Oracle and resolve customer issues, right? Within no time.
So I'm going to say it very definitively. The reason there are multiple hundreds of thousands of Oracle customers running on VMware technologies really is twofold. First of all, the fact that vSphere works. Secondly, and I think just as importantly, the fact that VMware did very, very wisely determine to have this total ownership policy, as well as creating what I consider and have considered for now 11 years to be the best Oracle support team on earth, embedded within the Oracle, the VMware Global Support Services system.
Okay, so essentially, we spoke about the metallic node 249.212.1. We spoke about the second pillar of support, the VMware total ownership support, right? We also spoke about the fact that Oracle doesn't certify infrastructure. It only certifies operating system. The two checkboxes to be kept in mind if you wish to get support from both the vendors, Oracle and VMware here. So for sake of time, I want to move on to the next slide, right? And this is essentially the third pillar of support, the TSSNET.org. And Don has also mentioned the fact that, VMware, we will leverage the support ticket the customers open with Oracle. We will use TSSNet if needed. And then VMware will contact Oracle on behalf of the customer if necessary. So these three essentially are the three pillars of support that we provide, or we can choose to use if we have to approach Oracle for any kind of support issues. All right. So as part of the wrap up, right? Essentially, these are some collaterals that we have put together, right? A lot of licensing collaterals. The Understanding VMware Oracle Support and Licensing Guide that's here in the link in the bottom of the slide as well. The external solution page for business critical application, essentially the Oracle virtualization, that's there as well here. And if I move to the next slide, that essentially is the one-stop shop that Don referenced in the start of the session. So essentially all Oracle on VMware, any of the white papers, whether that's best practices, whether that's Oracle RAC, whether that's Oracle on persistent memory, Oracle using PBRDMA drivers, any other important KB articles, any blog articles, whether that's Oracle on vSAN, Oracle on vWall, essentially anything and everything, right, that we have produced so far, it finds its home in the Oracle on VMware, the one-stop shop. And the link is there in the bottom of the slide here as well.
I think you've got it, Sudhir.
All right. And moving on. That's a bit about me.
What a good-looking guy. And there's me, not so much.
And there's a bit about Don as well. So, but I think we are at the end of towards the end of the session where we can now open up for some kind of Q&A.
So yes, please send in some questions. You can do it over the chat window. You can send us questions via email. We've been doing this for a very long time since Oracle-wise, between the two of us, I think we have 40 plus years of experience, and VMware or Oracle on VMware-wise, approaching 25 years of experience. So please reach out to us and ask us questions. Things keep getting better. They keep getting more involved. As I said before, we started on premises, moved to the software-defined data center, and now we've moved to the various different suite of VMware clouds, and then all the way back to the on-premises idea of a VMware cloud being on premises, such as VMware Cloud on Dell EMC or VMware Cloud on AWS Outposts. And there are more to come with that as well. So there are more questions. The basics still apply in licensing support, and everything's technical. And we'd love to continue to answer your questions whenever you see fit to ask. And that's it. So thank you, folks.